But since we are talking about log functions, there's just its inverse of it, okay? So just kind of review. When we have a to the m times a to the n, what does that turn into? A to the... You add them together. We're doing this section, yeah. So when it's a to the m divided by a to the n, what do we do with both the exponents? Subtract them. And then, of course, what we talked about last class as well, when you raise a power to a power, what are you doing both of those exponents? Multiplying. Good. All right, so let's go ahead and look at, take that information that you just found out. When we multiply 2 together, it means we're actually adding. When you divide, it means we're subtracting. And when you're raising a power to a power, that means we're actually multiplying, okay? So we'll take that information now and apply it to log functions. So if you look here, but it's the inverse. So look at the log base of a of u times v. Well, look up above it. What did we do with those exponents when we were multiplying? We added them. So that's exactly what we're going to do. We're going to break this up. Log a of u plus log a of v. You can split it out. And vice versa. So if I have two logs with the same base and I'm adding them together, you can combine them and multiply the arguments. That's what this is saying. So what do you think is going to happen when we divide the arguments? Subtract. Make sure you subtract it by the denominator. It's u divided by v. So it's going to be log a of u minus log a of v. There is a difference. So make sure you get those in the right order, okay? And then, of course, what happens when you raise a power to a power? What did we do? You multiplied. This is going to look a little bit different, but it's going to be the same idea. Keep in mind that we're still multiplying, okay, guys? So you take the exponent in, and you just set it in front. So it's actually n times multiply. And so you see that right there. Any argument raised to a power... Any argument raised to a power becomes the coefficients of that log function. Okay, just what you see here. The argument is u to the n. The n becomes the coefficients are being multiplied times the function itself. So it moves. It moves to the front. And so now we go over, and guys, the same is true for natural log. So just go ahead and write it out. I'm not going to repeat it. A mirror image. Except now instead of log, it's natural log, okay? But same idea. So let's go ahead and look at our first example. And guys, our first example is a great example because it addresses something I think we struggle with a little bit. How can I rewrite a root as a power? What is 5 to the 5th root? How can I write that as an exponential function? Close. It's really good. Look back up. Remember when we were talking about, at the beginning of these notes, we're talking about 2 raised to the, and I said, what's 2 to the raised to the 1/2 power? What was 2 to the 1/2 power? Square root. Very good. Square root. So what do you think 5 to the 5th root is? I kind of gave the answer. Tyson got that. It's the 1/5. It's a fraction. Let's use our rules to go ahead and simplify this. Well, what happens to the 1/5, guys? Goes to the front. Oops, not 1/2, 1/5. Guys, 5 raised to what power gives me 5? It's an identity. It's an identity we talked about last class. If the base and the argument are the same, it becomes 1. 5 raised to the first power is 5, correct? And so that's why it turns into 1. So you get 1/5 times 1, which gives you 1/5. On to number 2. What do we do with that 5, guys? Well, actually, yeah, what do we do with the 5? We do. We do. We can do that. So 5 times 7 is? What is a natural log of e? It goes away. Because if you remember, guys, how can I rewrite natural log? You see this? Does that look familiar to something we did over here? Same base, same argument. If that happens, they go away. So you're left with 1. So actually your answer is 35, right? Again, base and argument, if they are the same, then it goes away or it's 1. All right, what happens to 15 and 5, guys? Be careful. Move to the front. Guys, move your exponents. If an argument's raised to a power, move it to the front first. What's natural log of e, guys? 1. So really all you're left with is what, guys? 15 divided by 5. All right. This one, guys, we got to be a little bit creative with in the fact that let's go ahead and bring them together. Let's use the rules that we have in the box above. You see right here, subtraction here in the middle? So that means I could actually condense this into one natural log function. I could take number 4 and put those 2 natural logs in together and get this. What do I do with e to the 10th and e to the 4th? Divide them. When you're dividing with exponents, what are you actually doing with those exponents? Subtracting. So this actually simplifies to what's natural log of e, guys? 1. There is another way to do this, however, and I want you to just kind of put your pencils down and watch. What was the rule of advice I gave you guys before I dove into this problem? Do what? What was the advice I gave you? What's the first step you need to be doing when you're dealing with natural log with powers? Very good. So, it looks like this. Do y'all agree? What's natural log of e again?
1.
We're getting better at that. Good. So you're left with what? Which equals?
6.
Same answer. Different way of doing it, same answer, right? All works. So you have 2 different ways of going through it. What looks easier to you? Look down at what you did earlier and look down or look up at what this did. Which one do you think easier to you?
This one.
It is. And I want to show you that because I want you to notice that the first step should be moving all your exponents to the front. You cannot go wrong with that. You cannot go wrong with changing all of your arguments' exponents and moving them to the front. If you're asked to simplify, that should be your first step. Okay? Get a habit of doing it because it's best practice. All right. 5, 6, and 7, I want you to turn to. All right, so we're going to take the rules we saw in the box. You're welcome. And we're going to go ahead and expand those. So now what's going to happen is this. You're going to take every, not term, but you're going to take every part of the term and expand it out. You're going to split these functions out into multiplication and divisions, okay? So if you look, it's 3 times x squared divided by y. Do you see that? Anytime I say times, I'm going to add. Anytime I say divide, I'm going to subtract. So, log, well, maybe we can use a pen. Log of 3, and I said times x squared, correct? Which means plus log of x squared, and then I said divide by y, which means minus log of y. Do you follow what happened there? It was 3 times x squared, so it's log 3 plus log x squared. Do you see that? We split it out. And then finally, one last thing is, when you're expanding, guys, when it's asking to expand, you cannot have any arguments raised to a power. What do you think we're going to do with that 2? Move it to the front. So you end up with log of 3 plus 2 log of x minus log of y. It's minus y because it's divided by y. Do you see that? Okay. The next one, what I recommend doing, guys, on these is rewriting, get rid of the square roots and fifth roots and third roots if there is any, and rewrite it as an exponential, okay? Because it's easier to expand out. So this ends up becoming, and I'm just going to do it right here. 4x plus 1 ends up turning into 4x plus 1 to the 1/2 power. And that's all together, and then it's all together in parentheses, correct? So that whole thing is going to stay together. So when I expand it out, I'm going to keep that 4x plus 1 together. It can't get separated. And then what do we do to finish this off? Minus natural log of 8. And we have one last step, because what's the problem? Are we done here? We have an exponent. So put it in front. And it's expanded out. 1/2 natural log of the quantity 4x plus 1 minus natural log of 8. Same is true for number 10. Okay? Same is true for number 10. However, this one's just a little bit easier because it shows that it's squared. So keep it all together. So log base 6 of x minus 2 squared. Now this gets interesting because now it's going to be minus log of y. Here's the problem. You got a couple options here. You notice that it's log of y, or I'm sorry, it's y times z cubed. Do you see that? And what's the rule when we say times? What do? We add. But where's the location of this z? On the bottom. So we're kind of torn. So what I'd recommend is maybe doing something like this, using parentheses, meaning these two terms, or everything else that's in the parentheses, everything that's in the parentheses is going to be the denominator. And then follow the rule that you just said. Add log z cubed and close parentheses. Use the parentheses so that you can see that it's minus because these two are on the bottom. Think about it. It's x minus 2 squared divided by y, x squared minus 2, or squared divided by z cubed. Both of those are being divided, right? So that's why you got to group them together. So from here, I probably start moving stuff to the front. Distribute the minus sign. Do what?
Is it supposed to be log 6y?
It is. I got lazy. Thank you. Yep, that log base 6 needs to be there.